Hi, I'm going to help you walk you through this activity called Gravity. What is it? And first, I would recommend, rather than using the Google Doc version, I would recommend that you open it using Kami. So if you pop that out, it will look like this. And then you should add Kami to your computer. If you just Google Kami extension, you can add it to your computer and then it will open up and you'll be able to see it. Do not use Google Docs to open this, otherwise it will change the formatting. If you want to use Google Docs, then just use the link that I put in the course. The one thing about Google Docs is it won't let you draw a picture here, so that's the downside. You'll just need to submit your picture separately. So I went ahead and opened it up with Kami, and I'm going to shrink this down a little bit. There's going to be several different parts that are going to teach you a little bit about gravity and how it works in the solar system. So the first one is to watch a video about a little guy jumping on a planet. And you're going to watch this and you're going to decide what do you think is holding this guy down, and he's going to try and jump off the planet, things like that. So you're just going to go ahead and answer these questions and then draw a picture that shows what you learned about gravity from this video. And if you're using Kami for the first time, you can use text box and then you just click here and you can start writing something. Okay, I think blah, blah, blah. You don't have to have this color font. I would change that font, and I probably wouldn't put a highlighter on it. So I'm going to delete that. And then for the next part, you're going to be looking at this information. And I would take some time and read what it says at the beginning. And then you're going to analyze this data to see what this is showing. So here, these are the different bodies or planets, including the sun and moon. And this is their mass, their size, I guess. So it looks like, if you just look at this first number, it looks like maybe this would be the biggest planet, Uranus. But if you look at the exponent, that tells you how many zeros are going to be after that number, then maybe that is not the biggest one. So you want to look to see, obviously the sun is going to be the biggest one, but maybe next after the sun, you could see which one is the biggest. And this column is telling you how long it takes a rock to drop to the surface if you hold it 100 meters away. So if you hold it 100 meters up in the air from the surface and you drop it on Earth, it will take 4.51 seconds for it to hit the ground. Mercury, it will take 7.35 seconds. The sun would only take 0.42 seconds to drop it from the same distance. Of course, no one would do that because you would just burn up. But you can sort of see how the same distance of a rock falling on different planets would take a different amount of time. So the questions are going to ask you, what does that tell you? What does that tell you about the gravitational pull? If something is falling and it falls and it's really quick to hit the ground, what does that tell you about the gravitational pull? Is the pull stronger with a bigger planet, or is it stronger with a smaller planet? So those are some things that it's going to ask you to think about. And when you end for this number 3, you're going to answer what is that rule that you learned from this? If the mass of the body, if the planet mass is higher, if it's a bigger mass, will the gravitational pull be weaker or stronger? So this is sort of what I'm looking for you could say, the bigger or the smaller the body, and then you tell me, is it stronger or weaker, depending on that size of the body. Okay, when you get to C and D, you're going to be playing with a computer simulation. And so you're going to go ahead and click on this simulation link. And it says, I'm going to go ahead and move this over a little bit. You're going to click on model. So there's two options. I'm going to click on model. And then you're going to click the selection to show the sun and the earth, which is this one. This is the sun, earth, and moon. So there's different options, earth and moon. So first, I'm just going to do the sun and the earth. And then I'm going to click the boxes that show gravity and path. And they're using arrows to represent gravity. So the bigger the arrow, the bigger the force of gravity. Okay, so let's go ahead and push play, and we're gonna change the mass of the sun and see what happens. So I'm gonna go ahead and push play, and as you can see, hopefully you know by now, the Earth orbits around the sun. And here is how I change the mass of the different objects. So if I make the mass of the sun bigger, okay, what do you notice is happening to the Earth? Okay, what's happening to the gravitational pull if we make the sun bigger? And maybe I would even make the sun a little bigger just to see what happens after that. Okay, and then the next question is asking what would happen if the mass of the sun decreased. So you're going to go ahead and move that all the way down. I'm not going to do it for you because it's kind of fun to see what happens. All right, part 2, you're going to reset your simulation. And then you're going to click Earth and Moon this time. So no sun, Earth and Moon. Okay, so here's another pair that are affecting each other with their gravitational pull. And here it says we're going to just check gravitational force. Okay, and then we're going to play around with the mass of the moon, increasing and decreasing it, and play around with the mass of the Earth, increasing and decreasing it. So I'm going to go ahead and push play. Okay, and here we are, moon going around the Earth as it does. And now I'm going to play around with the mass of the moon. I'm going to make the moon bigger. Okay, so here, what would happen to the moon if the Earth's mass decreased? Okay, so here it's telling you to play around, and then the first question is asking, what if the moon's mass decreased? So I'm going to take the moon's mass and I'm going to shrink it down to half its mass. And then the next question is, what would happen to the moon if the Earth's mass increased? So after I do that, I might pause it, reset it, and then go ahead and see what happens if the Earth's mass increases. So at the end of all of these activities, I want you to explain kind of what you've learned using an example or two, and how the mass of an object affects its gravitational force. So if you notice when the Earth's mass gets bigger, how does that affect its gravitational force? If the Earth's mass gets smaller, what happens to its gravitational force? Okay, and you can even look back on some of these now that you've learned that, looking at the different masses of the planets, and what does that tell you about the gravitational force and how fast something will be pulled down from a distance of 100 meters. All right, I hope that helps. If you have any other questions, feel free to email or come to my Zoom.